When you look up at the night sky, what do you see? A beautiful, but seemingly random, scatter of stars and distant galaxies. It's easy to think of the universe as a chaotic place, with objects just floating around in the vastness of space. But what if I told you that's not the full picture? What if, on the largest scale imaginable, everything is connected in a way you never thought possible? Scientists have a name for this hidden structure that links every galaxy in the universe. They call it the cosmic web. So, what exactly is the cosmic web? Imagine a massive, invisible network of filaments stretching across the entire universe. These filaments are like cosmic highways, and galaxies aren't just floating randomly. Instead, they are found at the intersections of these filaments, like cities built along a grand, interconnected road system. Think of it this way: galaxies aren't isolated islands, they're nodes in a colossal web. Between these bright, galaxy-rich filaments are enormous, almost empty regions called cosmic voids. These voids are the great deserts of the universe, vast expanses with very little matter. So, the universe isn't a uniform soup of stuff. It's a structured web of filaments and voids, with galaxies clustered in the busiest intersections. Now, you might be wondering, what is this incredible structure made of? Here's where it gets even more mysterious. The vast majority of the cosmic web, about 85% of its mass, is made of dark matter. This is a substance we can't see, touch, or detect directly. It doesn't emit or reflect any light. So how do we know it's there? We can measure its gravitational pull. The gravity of this invisible dark matter is what shapes the cosmic web, forming a sort of skeleton for the universe. The normal matter we can see, like gas, dust, stars, and entire galaxies, is pulled by gravity and collects along these dark matter filaments. In a way, the visible universe that we observe with our telescopes is just tracing the outline of this unseen, underlying structure. It's like seeing the lights of cities at night outlining the shape of a continent. How did such a complex and organized structure form in the first place? To answer that, we have to go back to the very beginning, just after the Big Bang. In the early universe, matter wasn't perfectly smooth and uniform. There were tiny, almost insignificant differences in density from one place to another. Over time, billions of years, gravity got to work on these tiny fluctuations. The areas that were just a little bit denser than average started to pull in more matter, becoming even denser. Think of it like a cosmic snowball effect. Gravity pulled matter together into long, thin strands and concentrated it into dense knots where these strands met. As this process continued over billions of years, the magnificent cosmic web slowly emerged from the primordial soup of the early universe, shaping the cosmos into the structured web we see today. For a long time, the cosmic web was just a theory, a prediction from our models of the universe. It was an elegant idea, but scientists needed proof. That proof started to arrive as our telescopes became more powerful. Astronomers embarked on massive projects to map the positions of millions of galaxies. As they plotted these galaxies on a 3D map of the universe, a pattern began to emerge. It wasn't random at all. They saw clusters, filaments, and vast voids, exactly as the theory had predicted. The pattern was unmistakable. To confirm this, scientists ran sophisticated computer simulations, starting with the conditions of the early universe, and letting a virtual cosmos evolve according to the laws of physics. The results were stunning. The simulations produced a web-like structure that looked almost identical to what the telescopes were observing. Observatories run by NASA and international partners have since confirmed this large-scale structure, turning a fascinating theory into an observed fact about our universe. The cosmic web is more than just a static skeleton, it's a dynamic and life-giving system. The filaments aren't just made of dark matter and galaxies. They also contain vast rivers of hot, thin hydrogen gas flowing between the galaxies. This intergalactic gas isn't just sitting there, it's the lifeline for galaxies. As this gas flows along the filaments, it gets funneled into the gravitational wells of galaxies, providing them with the raw material they need to form new stars. So, galaxies don't just grow in isolation. They are constantly being fed and nourished by the cosmic web itself. It's a bit like a cosmic irrigation system, where the web provides the fuel that powers the brilliant star-forming factories we call galaxies. This flow of matter and energy is a crucial part of the universe's life cycle. So, where do we fit into this grand cosmic picture? Our own galaxy, the Milky Way, is not an exception. We are part of this web. We reside on a filament within a cluster of galaxies known as the local group. And this group itself is part of an even larger structure, the Laniakea supercluster. We are not isolated. We are deeply embedded in this cosmic system. Even the way our galaxy moves through space is influenced by the gravitational pull of the cosmic web. The gravity from nearby filaments and clusters guides our journey through the universe. Knowing this completely changes our perspective. We aren't just a tiny speck in a random void. We are part of a vast, interconnected structure, connected to everything else in the cosmos. Understanding the cosmic web is fundamental to understanding the universe. It's not just a cool visual, it solves some of the biggest puzzles in cosmology. First, it explains why galaxies aren't spread out evenly, but instead clump together in clusters and superclusters. It shows us how the universe evolved from a nearly uniform state after the Big Bang into the complex structure we see today. It also gives us a map of where dark matter is located, even though we can't see it directly. And finally, it reveals the process of how galaxies and stars get the fuel they need to form and grow. Without the cosmic web, the universe would be a far more uniform, and probably far less interesting, place. It is the architect of the cosmos. The next time you gaze at the night sky, remember what you're truly seeing. It's not just a vast, empty space with random points of light. It's an intricate tapestry. Every galaxy, every cluster, every star is woven into a magnificent cosmic web that stretches across billions of light years. We are not lost in chaos. We are part of a grand, cosmic design, a connected universe that is more organized and more beautiful than we could have ever imagined. Thank you for watching. If you enjoyed this journey into the cosmos, don't forget to like, subscribe, and hit the bell for more explorations of our amazing universe.